You'd think that creating some brilliant, game-changing algorithm is the finish line, right? Well, what if I told you that's actually only half the battle? Let's get into it because the real challenge isn't just inventing something new, it's proving it.
Okay, so just imagine this for a second. You've done it. You've spent months, maybe years, coding something that could totally change an industry. Everything from logistics to healthcare. You've got the secret sauce. But now what? How do you actually prove to the world that your sauce is the best one out there?
And that simple question, that's the heart of what we're talking about today. See, in the world of algorithms, it's just not enough to be brilliant all by yourself in a lab. You have to prove it. And the thing is, as we're about to find out, the whole system for proving it is kind of broken.
All right, so the first huge problem is what researchers call a fragmented evaluation landscape. It sounds complicated, but the idea is simple. It's like everyone is using a different ruler to measure with. And look, it happens for what seem like good reasons, right? I mean, a hospital logistics problem is totally different from optimizing a cloud server. But the end result? It's chaos. And that ruler we're talking about, in the tech world, that's called a benchmark. It's supposed to be a standard test, a level playing field where all these different algorithms can compete head-to-head to see which one is actually the best. But yeah, that's not really how it's working out.
Just take a look here. This really shows you the problem in black and white. Instead of one standard test for everyone, we've got this wild patchwork of different proving grounds. So folks in cloud computing, they're using something called CloudSim. Meanwhile, people working on, say, job shop scheduling are using a totally different set of problems. It means everyone is stuck in their own little world, their own little silo. So what, right? Why does this even matter? Well, this fragmentation has huge consequences. If you have standardized testing, it's simple. You get clear winners, everyone learns from each other, our collective knowledge gets bigger and better. But in the world we have now, it's a total apples to oranges comparison. We literally can't tell if we're making real progress, and that just slams the brakes on scientific advancement.
Okay, but that's not even the only issue. The next big problem is something called the reproducibility crisis. The best way to think about it is like this. Imagine trying to bake a prize-winning cake, but the recipe you were given is missing like half the ingredients and most of the instructions. Good luck with that.
And this isn't just me making up a metaphor. Researchers are pointing this out directly. When scientists publish their big, amazing results, they often leave out super critical details. And what happens then? Well, nobody else can replicate their work. It's impossible. The magic just vanishes because the method is basically a black box. And this right here shows you the difference perfectly. On one side, you've got good reporting. This is what we want to see. Everything's out in the open, exact runtimes, all the parameters they used, even the hardware details. But then, look at the other side, bad reporting. And sadly, this is way too common. It's just full of vague claims and missing info. You basically have to take their word for it because there's no way to check the work yourself. The good news is the fix is actually pretty straightforward. It's a simple 4-step recipe for getting this right. You publish your code. You list all your parameters. You detail the environment you ran it in, and you release the data. That's it. If everyone did this, the whole mystery ingredient problem would just disappear. Okay, so let's say we fix the rulers, and we get everyone to share their recipes. We're still not done. There's a third, absolutely massive hurdle, and that's the huge gap between how things work in a nice, clean lab versus the messy, chaotic real world. I mean, just look at these numbers. It's kind of staggering, isn't it? A whopping 90% of all algorithm testing happens in these pristine, predictable simulations. They're using fake, synthetic data. Only a tiny little sliver, just 10%, are ever tested out in the wild, in the messy, unpredictable real world. And this, right here, creates a massive credibility problem. You can have an algorithm that looks like an absolute genius in a simulation, but the moment it hits the real world, a factory floor, a hospital, a live cloud server, it can completely fall apart. So that amazing performance you read about in a paper, it often just doesn't translate into actual on-the-ground value. So, why does this huge gap exist? Well, the research points to a few key things. For one, the few real-world tests that do happen are usually really small scale, or they're super short. Plus, they often still rely on proxies instead of the real deal. We're seriously lacking big, long-term studies from actual industrial settings, and there just aren't enough published real-world datasets for people to use.
All right, so we've laid out the big problems, right? We've got fragmented testing, a reproducibility crisis, and this massive gap between the lab and the real world. So the big question is, how do we fix all this? Well, let's take a look at the blueprint for building a much better proving ground.
The most important thing to get here is that we need a major shift in how we think about this stuff. A fantastic algorithm isn't some magic silver bullet you can just drop into a problem. For it to actually work in the real world, it has to be part of a complete system, an entire architecture that's built for real people and their real messy problems.
And that means we have to think about all the stuff that doesn't show up on a simple performance score. You know, things like, can a person step in and override it if something goes wrong? Can the algorithm actually explain why it made a certain decision? Is it being constantly monitored and retrained? These are the practical, human-focused features that take an algorithm from being high-performing to being genuinely useful.
So after all that talk about benchmarks, reporting, and architecture, you might be thinking, okay, I get it, but why does any of this really matter outside of a computer science department? It's a fair question. Well, it matters because of this. When we get this stuff right, our cloud data centers run way more efficiently, and that saves a ton of energy. It means our supply chains get smarter so they don't break down during a crisis. It means ambulances get to people faster, which literally saves lives. This is all about unlocking the true potential of these amazing ideas to solve real-world problems and speed up innovation for all of us. So, I'll leave you with this one last thought. We already have the genius. The brilliant algorithms are out there. The question is, if we can finally build a fair, transparent, and realistic way to measure them, if we can standardize the test, just stop and think for a second. How much faster could that genius evolve?